This is the 2010 F equals ma, and this is problem number 10. So we have two blocks, one with a mass of m1 on top of another with a mass of m2, and they're on a horizontal surface. Now we have a rope that pulls horizontally on the bottom block, and we're asked to find the acceleration of our lower block. And there's kinetic friction between all surfaces, and the coefficient of that is mu. So let's draw a force diagram for m2. So let this be m2. There's the force of gravity, m2g, as well as the gravity from the top block, so m1 times g. There's a normal force that acts from the ground on our lower block. There's our force that we are pulling with, and there's a friction force that tries to go against it. And there's a friction force between this friction force is actually made of two forces. This friction force is equal to the friction force from the ground, so something like this, friction force from the ground, plus the friction force from the top block. So between here and here, those are the friction forces that are acting on block 2. So we find that when we're just considering this direction, since we know that the normal force and the gravity will cancel, we find that the total force on our block 2 is just m2 times a, where a is our net acceleration, and we have F minus the force of friction. So we have m2a is equal to F minus the force of friction between the block and the ground, minus the force of friction between the top block and the bottom block. So we have that m2a is equal to F minus mu, in this case is the normal force, which is m1 plus m2 times g, minus mu, and this is from between the top block, where the top block has a normal force of m1 times g. So what we find is that we have m2 over a is equal to F minus mu g to get m1 plus m2 plus m1, which we can simplify just to equal F minus mu g to m1 plus m2. Now we want to solve for just the acceleration, so we can divide both sides by m2. And so we get that the acceleration of the bottom block, when we apply this force, is equal to F minus mu g to m1 plus m2 all over m2. And that is our acceleration for the system.